Hi, you're welcome once again to Soulma's Solution. Today we are going to talk about the differences between rational and irrational numbers. In the previous video we looked at how to classify the real numbers under the real number system. Today we are going to look at the differences between rational and irrational numbers. We are going to talk about why some numbers are said to be irrational, and then what makes a number to be a rational number. My name is Solomon. When we talk about rational numbers, as we said in the last session, rational numbers can be written in the form a over b, where b is not equal to 0. B should not be equal to 0, because if b is equal to 0, that number does not exist, and so b should not be equal to 0. And so some examples are 5. The number 5 can be written in the form a over b, and so 5 is a rational number. 2/3 is a rational number. -7/2, -10, 3.2, all these numbers can be written in the form a over b. Square root of 4 is equal to 2, and so square root of 4 is also a rational number. We have square root of 9. Square root of 9 is equal to 3, and so 3 can be written in the form a over b, that is 3 over 1, and so square root of 9 is also a rational number. The cube root of 8 is also a rational number. The cube root of 8 will give you 2, is equal to 2, okay, and so the cube root of 8 is also a rational number. What it means is that what number can multiply itself, or what number can be multiplied by itself 3 times to get 8? What number can be multiplied by itself 3 times to get the number what? 8. And the number is 2. 2, if you multiply 2 by 2 times 2, okay, 2 by 2 will give you what? 4, and then 4 by 2 will give you what? 8. And so the number that can be multiplied by itself 3 times to get 8 is what? 2. And so the cube root of 8 is equal to 2. And 2 can be written in the form a over b. Okay, and so cube root of 8 is also a rational number. Good. On the other side, irrational numbers cannot be written in the form a over b. Rational numbers can be written in the form a over b. Irrational numbers cannot be written in the form a over b. For example, the number e is an irrational number. It cannot be simplified to get a whole number. The number pi cannot be simplified to get a whole number, and therefore it cannot be written in the form a over b. The square root of 2, square root of 3, and the square root of 5. All these numbers can never be simplified to get a whole number, and so they cannot be written in the form a over b. Unlike the square root of 4, it can simplify down to 2. The square root of 9 will give you 3. The square root of 2, nothing can be done to the square root of 2. The square root of 3 and the square root of 5, the same thing, and so they can never be written in the form a over b. Alright, then the decimal forms of rational numbers may either terminate or recur. What it means is that the numbers, or the rational numbers, if you change them to decimals, their decimal forms may either terminate or what? Recur. For example, if you have the fraction 5/2, if you change it to decimal, you are going to get 2.5, which is a terminating decimal. The decimals have an end. It does not keep repeating. And then if you have 9/25, is also equal to, or the decimal form is 0.36. It has an end. It does not continue to infinity. And so decimals of this form are what we call terminating decimals. We call them terminating decimals because their decimals have an end. They terminate. Good. And if you have a rational number like 2/3, if you change it to decimal, you are going to get 0.66666. It keeps repeating. It has no end. That's what we refer to as recurring. It does not end. It continues to infinity. And so we can write this in this form, 0.6 with a dot on top. or 0.6 with a bar on top of the number that is repeating. In this case, the number that is repeating is 6, and so the repeating pattern of this number is what? Just 6. And so you write 0.6, then you put a dot on top of the number that is repeating. And so this is the same as this, and this is the same as that. That's a shorter way of writing this long decimal. 24 over 11 is also a rational number. It's in the form a over b, of course. We change to decimal, that's the decimal form, 2.181818. It continues to infinity. That's what we refer to as recur. It keeps reoccurring. And then the repeating pattern of this number is 1 8. You see, 1 8 1 8 1 8. So in short, you write it as 2.18 with a bar on top of the number or the digits that are repeating. The digits that are repeating are 1 8. Or you can write 2.18 with dots on each of the digits that are recurring. Alright, so the repeating pattern of this number is 1 8, and the repeating pattern of this decimal is what? 6. So decimals of this form are what we call, or what we refer to as recurring decimals. Alright, so the decimal form of rational numbers may either what? Terminate, as in this form, or recur, as in this form. Good. On the other side, the decimal forms of irrational numbers neither terminate nor what? Recur. So it's like the direct opposite. The rational numbers, they terminate or recur, and then the irrational numbers, the decimal form neither terminates nor what? Recur. For example, the value of e is 2.718281828459. It continues to what? Infinity. That's what we mean by it does not terminate. It does not have an end. Okay, good. And then it does not recur. When you look at the decimals, none of them is repeating. It's not repeating, as in this case where we have 1 8 1 8 1 8, and it's not repeating, and then it has no end. So we say it's neither terminate nor what? Recur. Good. Pi is the same thing. It has no end, and then what? It is not recurring. The square root of 2, the square root of 3, all these numbers are irrational numbers because what? Their decimal forms have no end, and it's not recurring. Good. You can check other irrational numbers and then see what we are talking about. And so decimals of this form, which neither terminate nor recur, are what we refer to as non-terminating and non-recurring decimals. So the decimal form of rational numbers either terminate or what? Recur. But on the other side, the decimal forms of irrational numbers, they neither terminate. In fact, it does not terminate, and then what? Does not recur. Alright. So these are some of the few differences between rational and what? Irrational numbers. The rational numbers can be written in the form a over b, while the irrational numbers, they cannot be written in the form a over b. And then when you change a rational number to decimal, the decimal form may either terminate or what? Reoccur. On the other side, when you change an irrational number to decimal, the decimal neither terminate nor what? Recur. Alright, thanks for watching. Like and share this video, and don't forget to subscribe.